Okay, in this video, we are going over dimensional analysis. So dimensional analysis talks about comparing dimensions, different and converting between different types of dimensions and measurements. All right, so you can see here problem number 1. Okay, we got problem number 1 here, 7.2 meters, and it wants us to convert that to feet. And it tells us that 1 meter equals 3.28 feet. All right, so when you're trying to convert different measurements to other measurements, different dimensions to other dimensions, then you want to use ratios and proportions. So just a little refresher. Okay, a ratio often looks like this, comparing two quantities to each other. So 3, sometimes you'll have a colon that compares 3 to 8. That's a ratio. You could also write a ratio as a fraction. So 3 over 8, and that's what we're going to be using is fractions as ratios. Okay. Now, a proportion is going to be useful, and we'll see why in a minute, because a proportion compares one ratio to another one, but they're equivalent. So a proportion is two equivalent ratios. So 3/8, for example, is equivalent to 6 over 16 because you could multiply 3 times 2 and 8 times 2 and get a equivalent fraction of 6 over 16. Okay, so just a quick refresher, ratios, we're going to see them as fractions. Ratios are just a way to compare two quantities. And a proportion is where you set two ratios equivalent to each other. All right. So number 1, okay, we're trying to figure out how many feet are in 7.2 meters. So 7.2 meters to feet. All right. So the first thing you want to do is set up the ratio that they give you. So in the parentheses, they tell us 1 meter is equal to 3.28 feet. So what I'm going to do is write that as a fraction. 1 meter compared to 3.28 feet. So there's my first ratio. I'm going to set it equal to what I'm looking for. And you want to keep, if you started with meters in the numerator up top, then you want to keep your other fraction, your other ratio, you want to keep meters up top in the numerator as well. So I'm going to put 7.2 meters. We're trying to figure out what that compares to in feet. Okay, and so we are trying to figure out this question mark. And instead of a question mark in math, when we don't know of a quantity or value, we use a variable. So instead of a question mark, I'm going to put X. Okay, so we are trying to figure out how many feet are in 7.2 meters using this proportion. We just set up two ratios that are equivalent. Once we find out what X is, we will know what will make this proportion equivalent. So the way you're going to figure this out, the easiest way that I enjoy is doing cross multiplication. So I'm going to cross multiply. So in other words, I'm going to multiply 1 meter times X feet. So 1 times X. So 1 times X is going to be equivalent to what the other 2 that I multiply. In this case, it'll be 3.28 times 7.2. So 3.28 times 7.2. Okay, so I'm cross multiplying and setting the two sets of quantities that I'm multiplying, I set them equal to each other, just like the equal sign we had in our proportion originally. Okay, so now I'm going to do the multiplication. So 1 times X is X. I still have the equal symbol, and 3.28 times 7.2, that I'm going to do in my calculator, 3.28 times 7.2, and I get 23.616. All right, so we just figured out, oh, x equals 23.616. Well, x, if we go back, looking up here, x was going to be represented by feet. So we just figured out 23.616 feet. So I'm going to put that next to the value. And that tells us that we just figured out that in 7.2 meters, there are 23.616 feet. So we just converted 7.2 meters into feet. All right. So that's the first example. So let's try it one more time. So example number 2, 4.3 pounds to kilograms. So we're converting pounds to kilograms. And it tells us 1 kilogram is equal to 2.2 pounds. So the first thing I want to do is set up my first ratio with what they've given me. Okay, so they give me, 1 kilogram. So I'm going to write 1 kg compared to 2.2 pounds. And we're going to set that equal to what we're looking for, which we're looking for how many kilograms. So x kilograms, how many kilograms are in 4.3 pounds? Okay, so the difference here is now we have x is in the numerator, whereas in our first problem, it was below in the denominator. The reason for that is, again, like I said earlier, when you set up your first, ratio, you need to stick with whatever's up top, whatever unit of measurements up top needs to stay up top on the other ratio. So like kilograms was up in the numerator on the first ratio I set up, so it needs to stay in the numerator on the up top in the second ratio. And pounds was in the denominator in the first ratio, needs to stay in the denominator in the second ratio then. Okay? So that's why we set it up like this. And now we can cross multiply. So when I cross multiply 2.2 times x and 1 times 4.3. So let's do 2.2 times x equals the other set, 1 times 4.3. All right. So 2.2 times x is 2.2x. That's going to equal 1 times 4.3 is just 4.3. All right, so now, but I'm trying to solve for x. So in order to solve for x here, I've got to do the inverse operation. Right now, it's 2.2 times x. So if I'm multiplying here, I need to divide by 2.2 in order to get x by itself. If I divide by 2.2, I have to do it on the other side as well. So now I've got x on the left side equals 4.3 divided by 2.2, which if you put in the calculator, and I'll round, but I got 1.95 if you round to the nearest hundredths place. And 1.95, well, what units is that going to be? Well, look back at what, up in the right, what x was. X was supposed to be in kilograms. So we just figured out this is 1.95 kilograms. And that's our answer as far as how many kilograms are in 4.3 pounds. Well, there's 1.95 kilograms equivalent to 4.3 pounds. And we just figured that out by using ratios and comparing them and doing cross multiplication and solving for our variable. So hopefully that helps you have a better understanding of how to convert certain measurements to other measurements. Okay, we call that dimensional analysis. But I will have also more further examples. If you want more practice and more visual examples, I will have that in part 2 of converting measurements.